All right, welcome in. The NVIDIA RTX 5090 is officially here. And wow, it is an absolute beast for local AI. I mean, we're talking about a massive 32 gigabytes of ultra-fast GDDR7 memory built on that brand new Blackwell architecture. It literally brings data center power right to your physical desk. But as you might have experienced, getting this bleeding-edge hardware to actually play nice with Windows 11 for fine-tuning large language models, yeah, that has been a bit of a wild ride for early adopters. So today, we are diving into a detailed explainer based on Unsloth's latest documentation and recent walkthroughs. We're going to look at exactly how to flawlessly fine-tune LLMs locally on Windows 11 using the RTX 5090. And our absolute secret weapon for pulling all of this off, Unsloth Studio.
So here's our roadmap for this explainer. We'll quickly tackle the Blackwell architecture challenge, prep Windows 11, install Unsloth Studio, walk through the actual fine-tuning workflow, and then finally look at exporting your shiny new custom LLM. Let's just jump right in.
Starting off with Section 1, the Blackwell architecture challenge.
Look, if you've just dropped serious cash to plug in your shiny new RTX 5090 and you immediately tried to run a standard PyTorch training script, you've almost certainly asked yourself this very frustrating question. Why is my new 5090 crashing? You might be staring at a terminal output that just abruptly halts with a cubls_status_execution_failed error, or maybe it warns you that no kernel image is available. It's maddening, right? You literally have the most powerful consumer GPU on the planet sitting in your rig, and it fails on the very first matrix multiplication when you try to fine-tune a model.
So what is actually happening behind the scenes here? Well, the core issue comes down to what's called the SM-120 compute capability. Think of compute capability as the specific architectural instruction set, basically the language that tells your software how to talk to NVIDIA's hardware. SM-120 is the brand new language for these Blackwell GPUs. The problem is that, at least in early 2026, standard stable releases of PyTorch simply do not have the precompiled kernels to recognize this brand new architecture yet. Standard PyTorch 2.6.0 knows perfectly well how to talk to older architectures like Ada Lovelace or Ampere, but it looks at the 5090 and basically says, I have no idea what to do with this. Normally, bridging this gap natively means messing with bleeding-edge nightly builds of PyTorch or CUDA 12.8, which introduces a whole new layer of instability. But don't worry, the tools we are looking at today are going to handle this entire compatibility headache completely automatically for us.
Moving right along to Section 2, prepping Windows 11. Before we install anything, we need to talk about a silent killer lurking right in your OS. Out of the box, Windows has this strict legacy 260-character limit on file paths, known historically as max_path. Now, when you're training LLMs, the software relies heavily on downloading these deeply nested cache files and extremely long hash directory names directly from Hugging Face. It's honestly like trying to stuff a massive, deeply branching tree into a very shallow box. Eventually, the branches are just going to snap, your installation will silently fail, or worse, corrupted weights will download without throwing an immediate error, or you'll get hit with a catastrophic path-too-long exception right at the finish line when you're trying to save your massive new model checkpoint.
Luckily, fixing this is actually super easy. You literally just open PowerShell as an administrator and run a command to change a registry key. You just target the file system control set and change the long paths enabled value to 1. After that, just reboot your machine. Boom. This one-time fundamental fix tells Windows it can now handle file paths up to 32,000 characters long, which completely eliminates those bizarre silent cache errors that always seem to plague local AI setups.
One more quick Windows tip here. You really need to keep a close eye on your memory allocation. Windows always tries to be helpful by pooling system resources, so it often attempts to dynamically allocate half your regular system RAM as shared GPU memory. This happens all the time if you have an integrated GPU running alongside your 5090. But for AI training, we don't want helpful pooling. That's your enemy. You want absolute, unadulterated access to your massive 32 gigabytes of dedicated GDDR7 VRAM. You can dive into your Windows graphics settings to ensure the fine-tuning environment relies exclusively on your dedicated 5090 VRAM. That prevents bottlenecks and leaves your slower DDR5 system RAM entirely free for the CPU to handle loading those raw datasets.
All right, let's get into Section 3, installing Unsloth Studio. So why are we using Unsloth specifically? Well, the underlying metrics are just staggering. Unsloth uses highly optimized custom Triton kernels that completely bypass the standard memory-heavy PyTorch AutoGrad engine. By manually deriving gradients, which is the core math required for your model to learn, Unsloth actually makes your fine-tuning process up to 2 times faster. But even more importantly for us local users, it uses up to 70% less VRAM compared to standard Hugging Face implementations. It is basically magic. This level of optimization is exactly what allows you to train significantly larger models, stuff you probably thought required massive cloud compute, right on your desktop.
And honestly, the best part is how they've completely solved the installation nightmare. The old way of doing this meant manually matching PyTorch nightlies with Triton versions inside some messy WSL or Conda environment. Agonizing, right? It's incredibly prone to CUDA version mismatches and segmentation faults, especially with the 5090's bleeding-edge architecture. Contrast that with Unsloth Studio's installer. It's just one short line in PowerShell. IRM https:/unsloth.ai/install.ps1iex. That's it. This brilliantly automated script detects your specific system architecture, creates an isolated virtual environment, and handles all those tricky Blackwell dependencies for you. It even builds the optimized runtime binaries in the background. You barely have to lift a finger.
I really love this part. Once that installer finishes, all you do is type Unsloth Studio into your terminal. It spins up a local web server, and you just point your browser to localhost port 8088. No messy Python scripts to write, no debugging code. You are instantly greeted with a clean, super intuitive, no-code web interface, and the whole thing is running completely securely right on your local machine.
Which brings us to Section 4, the fine-tuning workflow.
Okay, so the Unsloth Studio UI is essentially built around 4 main pillars. First up is the model section. This is where you select your base architecture. You can easily pull down something highly capable like Qwen 3.5-9b or Llama 3 straight from the Hugging Face hub. Second is the dataset section. You literally just upload your proprietary JSON, CSV, or even raw text files, and the Studio auto-formats it all for instruction tuning. Third, the Parameters tab. We want to select QLoRa here, which uses 4-bit quantization. That is absolutely crucial for maintaining high VRAM efficiency without sacrificing your output quality. And finally, the Training and Config tab, where you set your epochs and just watch the live loss curves as your model learns. This entire visual dashboard is such a game changer because it completely eliminates the need to maintain those fragile Jupyter notebooks, hundreds of lines of Python code replaced by a few clicks.
And what makes this workflow so incredibly powerful is how Unsloth leverages your specific hardware. The RTX 5090 has this massive memory bandwidth of 1792 gigabytes per second. Standard libraries often can't feed data fast enough to actually keep the GPU compute cores busy, so they leave tons of performance on the table. But Unsloth's custom kernels, they are designed to be so radically cache efficient that they fully saturate that immense bandwidth. You are squeezing every single drop of performance out of that GDDR7 memory. You're not just casually using a 5090, you are pushing it to its absolute theoretical limits.
Finally, Section 5, exporting your custom LLM.
So the training finishes up. The loss curve looks great. Now what? Unsloth Studio doesn't just dump a bunch of raw, unusable weight files on you. Right inside the browser, you can open their built-in chat interface and actually talk to the exact model you just trained. You can instantly test its new domain knowledge, verify the custom behavior, and make sure it's answering exactly how you taught it to. And once you're satisfied, exporting it is literally a single click. You can kick it out to the GGUF format if you want highly optimized local CPU or mixed inference, or go with standard 16-bit safe tensors if you're prepping for a bigger production deployment. It packages the whole shebang up neatly, ready to run, straight from your desktop.
So we've navigated the weird Blackwell architecture quirks, we told Windows 11 to get out of its own way, and we completely bypassed messy coding using Unsloth Studio. You have officially reached the peak. So my final question for you is this. What are you going to build now that you have the power to localize and train massive models flawlessly on your own desk? The barrier to entry for true, incredibly powerful local AI is just gone. Get out there and build something amazing.